So dear students, welcome back to all fours e-learning classes. Okay, now problems on previous concept, pair of tangents. The pair of tangents from 2, 1 to the circle x square plus y square equal to 4 is. Students, here this is the circle s equal to 0. Question, pair of tangents. The pair of tangents from the point 2, 1. The combined equation of these two tangents is what? We have formula s1 square equal to s into s11. The combined equation of the tangents. The equation of the pair of tangents drawn from the point x1, y1 to the circle s equal to 0 is s1 square equal to s into s11. Given circle is s equal to x square plus y square minus 4 equal to 0. Given point means x1 comma y1. This is 2 1. Now pair of tangents, equation of pair of tangents. Pair of tangents is s1 square equal to s into s11. s1 square equal to the equation of pair of tangents is s1 square equal to s into s11. Next, here s1 square, s1 for given circle x1 plus y1 minus 4 whole square. S means x square plus y square minus 4 into s11 x1 square plus y1 square minus 4. S1 x1 plus y1 minus 4 whole square equal to s x square plus y square minus 4 into s11 x1 square plus y1 square minus 4. Next, here x1 means 2, here it is a 2x plus, here y1 is 1, y minus 4 whole square equal to, next, x square plus y square minus 4 as it is. Here x1 square 4, y1 square 1 minus 4. Okay, next, expand this. Here 2x plus y minus 4 whole square, a plus b minus c whole square, it is 4x square plus b square plus c square plus 2ab 4xy minus 2bc, which is minus 8y 2ac minus, next, minus 16x equal to, here 4 cancel, right side x square plus y square minus 4. Now taking left side, this is the final answer. 4x square minus x square, it is 3x square. Here y square cancel. Okay, next, 4xy, next, minus 16x minus 8y minus 8y, constant 16 Where minus 4 taking left side, it is 20 equal to 0. Okay, the combined equation of the tangents is 3x square plus 4xy minus 16x minus 8y plus 20 equal to 0. Okay, next problem. The pair of tangents from origin to the circle x square plus y square plus 4x plus 2y plus 3 equal to 0. The pair of tangents from origin to the circle. Pair of tangents drawn from origin to the circle x square plus y square plus 4x plus 2y plus 3 equal to 0. The combined equation of these two tangents is what? Actually, these two lines passing through the origin, the combined equation of these two in the form ax square plus 2hxy plus by square equal to 0. Homogeneous equation. We have formula for this directly. We know that the pair of tangents the equation of pair of tangents drawn from origin to the circle x square plus y square plus 2gx plus 2fy plus c equal to 0 is gx plus fy whole square equal to c of x square plus y square. gx plus fy whole square equal to c of x square plus y square. Here we know that the pair of tangents drawn from origin to the circle x square plus y square plus 2gx plus 2fy plus c equal to 0 is gx plus fy whole square equal to c of x square plus y square. Now here for this circle the pair of tangents drawn from origin to this circle according to this formula, here g equal to what? 2x, f is what? 1, 2x plus y whole square, c constants 3 of x square plus y square. Okay, this is the final answer. The combined equation of the tangents is 2x plus y whole square equal to 3 of x square plus y square. This is in the form ax square plus 2hxy plus by square equal to 0. Okay, next side heading touching circles. Observe here. Two circles are said to be touch each other. The two circles are said to be touch each other if they have a point P in common. This is the point P. The two circles said to be touch each other if they have a point P in common. The point P is called a point of contact. Point of contact of the circles. The point P is called point of contact of the circles. Here two circles are said to be touch each other if they have a point P in common. The point P is called a point of contact of the circles. Observe here. Here, for suppose one line touches the circle, then this is what? Tangent of this circle. This point is called point of contact of the tangent. This point is called point of contact of the tangent. Now here the two circles touch each other. The point P is called point of contact of the circles. difference between these two. Here this is point of contact of the tangent. Here this point is what? Point of contact of the circles. Okay, next set heading common tangent. Common tangent. A line L equal to 0. A line L equal to 0 is said to be common tangent of the circles. If the line L equal to 0 touches both the circles. Here two circles given, S equal to 0 and S dash equal to 0. Here this is some S equal to 0. Circle name is S dash equal to 0. If a line L equal to 0, this is the line L equal to 0. Here the line L equal to 0 touches two circles, S equal to 0 and S dash equal to 0. Then this line L equal to 0 is called common tangent of the circles S equal to 0 and S dash equal to 0. Once again, a line L equal to 0 is said to be common tangent of the circles S equal to 0 and S dash equal to 0 if the line L equal to 0 touching both the circles S equal to 0 and S dash equal to 0. Here common tangents. This is the common tangent. This is also common tangent. This line touches both the circles. This is also common tangent. Okay, these are the common tangents. Okay, here common tangents two types. Common tangent two types. Common tangents two types. One is direct common tangents. Second one, transverse. Here direct common tangents, transverse common tangents. Here direct common tangent means, observe, a line, a common tangent L equal to 0. A common tangent L equal to 0 is said to be direct common tangents of the circles S equal to 0 and S dash equal to 0. If the circles S equal to 0 and S dash equal to 0 lies same side of the line L equal to 0. Right, this is the direct common tangent. Here what is direct? Here common tangents are two types, direct common tangents and transverse common tangents. Here a line L equal to 0, a common tangent L equal to 0 is said to be direct common tangents of the circles S equal to 0 and S dash equal to 0. If the two circles S equal to 0 and S dash equal to 0 lies same side of the line L equal to 0. This is the direct common tangent. Here 1, 2, 3, 4. Observe. Here this is the direct common tangent. This is also direct common tangent. Direct common DCT means direct common tangent. This is direct common tangent. Okay. These two are the direct common tangent. Observe. Here two circles lie on the same side of the line L equal to 0. Here also same two circles lies on the same side of the line L equal to 0. Next, transverse common tangents. Transverse common tangents. Here a line a common tangent L equal to 0 is said to be transverse common tangent of the circles S equal to 0 and S dash equal to 0. If the two circles S equal to 0 and S dash equal to 0 lie on the either side of the line L equal to 0, it means opposite side of the line L equal to 0. Now this is the transverse common tangent. This is transverse common tangent. TCT means transverse common tangent. Now this is also transverse common tangent. Here two circles lie on either side of the line L equal to 0. Therefore this common tangent is called transverse common tangent. Right? Here out of 4, here first one and fourth one, these two lines are direct common tangents. From third and fourth, from third and second, here these two lines are transverse common tangent of the circles. Once again, here what is direct common tangent? If the common tangent L equal to 0, a common tangent L equal to 0 is said to be direct common tangent of the circles if the two circles lie on the same side of the line L equal to 0. Okay, now these two are direct common tangents. Here two circles lie on the same side of the line L equal to 0. This is L equal to 0. These two are direct common tangents. Next, transverse common tangents. The line, if a common tangent L equal to 0 is said to be transverse common tangent of the circles S equal to 0 and S dash equal to 0 if the two circles lie on either side of the line L equal to 0. Now these two lines, second and third diagram, these two lines are called transverse common tangent of the circles. Right, next, relative position of two circles. Relative position of two circles. Let S equal to 0, comma S dash equal to 0 are two circles. Let S equal to 0, comma S dash equal to 0 are two circles. Let C1, comma C2 are centers Let C1 comma C2 are centers and R1 comma R2 are radii. R1 comma R2 are radii of circles S equal to 0 and S dash equal to 0 respectively. Observation, let S equal to 0, S dash equal to 0 are two circles. Let C1 comma C2 are centers and R1 comma R2 are radii of circles S equal to 0 and S dash equal to 0 respectively. Now first condition, it is D equal to no need D here. So these conditions are very, very important. C1, C2. First condition, observe C1, C2 greater than R1 plus R2. Here C1, C2 means distance between the centers. C1, C2 means distance between the centers. R1 plus R2 means sum of radii. In this case, relative position of two circles. Right. Right. Here, if C1, C2 greater than R1 plus R2, Then here, observe here C1 C2 distance between the centers. C1 C2 distance between the centers greater than R1 plus R2 plus R2. Here C1 C2, observe this diagram, C1 C2 distance between the centers is greater than sum of radii R1 plus R2. Here R1 is the radius of this circle, R2 is the radius of this circle. Observe this diagram. If C1 C2 greater than R1 plus R2, then one circle completely lies outside of the first circle. Here this is the second circle, this is the first circle. Here second circle completely lies outside of the first circle. If C1 C2 greater than R1 plus R2, observe this distance C1 C2 and R1 plus R2. In this case C1 C2 greater than R1 plus R2, one circle completely lies outside of the other circle. In this case common tangents. This is the direct common tangent, this is the common tangent. This is the common tangent. Right? Here total 4 common tangents are exist. In this case, one circle completely lies outside of the other circle. Here 4 common tangents are exist. These two are direct common tangents. These two are transverse common tangents. Transverse common tangents. Here number of common tangents. First case, number of common tangents. Number of common tangents equal to 4. Direct common tangents 2. Transverse common tangents 2. Direct common tangents are 2. Transverse common tangents are 2. Here circle's position is what? One circle completely lies outside of the other. This is the circle's position. This is the main important. Here one circle completely lies outside of the other. Right, students, here S equal to 0 and S dash equal to 0 are two circles. But C1 comma C2 are centers. The R1 comma R2 are radii of the circles S equal to 0 and S dash equal to 0 respectively. Here C1 C2 greater than R1 plus R2. In this case, one circle completely lies outside of the other. In this case, number of common tangents 4, 2 direct to 2 transverse. Number of common tangents 4, direct common tangents equal to 2, transverse common tangents equal to 2. Okay, next second one. C1 C2 equal to R1 plus R2. Right, first case is C1 C2 greater than R1 plus R2. Second case is C1 C2 equal to R1 plus R2. C1 C2 equal to R1 plus R2, in this case circle's position. Right? Here C1 C2 equal to R1 plus R2. C1 C2 means what? Distance between the centers. Distance between the centers. Here C1 C2 equal to R1 plus R2. If C1 C2 distance between the centers equal to sum of radii. This is C1, this is C2. Next it is R1, R2. Yeah, C1 C2 equal to R1 plus R2. In this case, we say that two circles touch each other externally. Two circles touch each other externally. Here C1 C2 equal to R1 plus R2. C1 distance between the centers equal to sum of radii. In this case, two circles touch each other externally. Here point of contact is external. Here point of contact is external. This circle touching this circle externally. Therefore, this point is called point of contact of the circles. Here point of contact is external. Point of contact is external, and also here point of contact divides. The two circles touch each other externally. The point of contact divides the line joining C1 and C2 in the ratio R1 is to R2 internally. Once again, here the two C1 C2 equal to R1 plus R2. In this case, we say that two circles touch each other externally, and here this circle touching this circle externally, and here this is the point of contact of the circles. This point divides C1 C2, the line joining C1 and C2 in the ratio R1 is to R2 internally. Here point of contact is external, but point of contact divides C1 C2 in the ratio R1 is to R2 internally. In this case, number of common tangents. In this case, number of common tangents what? Number of common tangents. It is common tangent. It is also one common tangent. Next, it is one common tangent. Here, total here 3. Here, 2 direct common tangents, 1 transverse common tangents. In this case, number of common tangents. Number of common tangents equal to 3. Direct common tangents 2. Direct common tangents 2. Transverse common tangents 1. Here, if C1 C2 equal to R1 plus R2, two circles touch each other externally. Number of common tangents 3, 2 direct common tangents, 1 transverse common tangent. Okay, next third case. Modulus of R1 minus R2 less than C1 C2 less than R1 plus R2. Right. In this case, two circles intersect each other. In this case, two circles intersect each other. Here, these two are what? Point of intersection of the circles. Point of intersection of the circles. If modulus of R1 minus R2 less than C1 C2 less than R1 plus R2. Here, first case is what? C1 C2 greater than R1 plus R2. Second case is what? C1 C2 equal to R1 plus R2. Third case, C1 C2 less than R1 plus R2. The same time, C1 C2 is greater than modulus of R1 minus R2. Here, third case is very, very important. Here, first case is C1 C2 greater than R1 plus R2. Second case, C1 C2 equal to R1 plus R2. Third case, C1 C2 less than R1 plus R2, and also C1 C2 greater than modulus of R1 minus R2. It means modulus of R1 minus R2 less than C1 C2 less than R1 plus R2. In this case, two circles intersect each other. Two circles intersect each other. A circle's position this case, two circles intersect each other. Here, point of intersection of the circles exist. Here, these two are the point of intersection of the circles. Modulus of R1 minus R2 less than C1 C2 less than R1 plus R2. In this case, we say that two circles intersect each other. In this case, this is what? Common chord. This is what? Common chord of the circles. If the two circles if the two circles intersect each other, the common chord, this is called common chord of the circles. Okay, now in this case, common tangents. Common tangents. Here, two common tangents exist, and two common tangents are called direct common tangents. Here, common tangents. Number of common tangents equal to 2. Number of common tangents equal to 2. direct common tangents equal to 2, transverse common tangents equal to 0. Right? Next, fourth one. Here C1, C2, sum of radii cases over. First case C1, C2 greater than R1 plus R2. Second case C1, C2 equal to R1 plus R2. Third case C1, C2 less than R1 plus R2. Now sum of radii cases over. Now difference of radii. Difference between the radii. Now here C1, C2 greater than modulus of R1 minus R2 completed. Now in order C1, C2 equal to modulus of R1 minus R2. Modulus of R1 minus R2. C1, C2 equal to modulus of R1 minus R2. In this case, right. In this case, two circles touch internally. Two circles touch each other internally. Here, second case is what? C1, C2 equal to R1 plus R2. C1, C2 equal to R1 plus R2, then the two circles said to be touch each other externally. If C1, C2 equal to modulus of R1 minus R2, then the two circles are said to be touch each other internally. Touch each other externally, touch each other internally. Right. In this case, only one common tangent is exists, that is direct common tangent. Right. In this case, the circle's position is what? Two circles touch each other internally. Two circles touch each other internally. You C1, C2 equal to modulus of R1 minus R2. Then the two circles are said to be touch each other internally. In this case, common tangents 1. Common tangents equal to 1. 1 is direct common tangent. Transverse common tangent 0. Okay, next, here the two circles touch each other internally. Then this point is called point of contact of the circles. Here, this point is called point of contact of the circles. Here, the point of contact divides the line joining C1 and C2 in the ratio R1 is to R2 externally. This is the point of contact. The two circles touch each other internally or externally. If the point of contact of the circles is exist, the two circles touch each other externally. The point of contact divides C1 C2 in the ratio R1 is to R2 internally. The two circles touch each other internally. The point of, this is what? Point of contact of the circles. Here point of contact divides the line joining the centers C1 and C2 in the ratio R1 is to R2 externally. Here point of contact is internal, but point of contact divides line joining C1 and C2 in the ratio R1 is to R2 externally. This here number of common tangents 1, that is direct common tangent. Last one. Fifth one. C1, C2 less than modulus of R1 minus R2. C1, C2 less than modulus of R1 minus R2. Here third case, C1, C2 greater than modulus of R1 minus R2. Fourth case, C1, C2 equal to modulus of R1 minus R2. Here fifth case, C1, C2 less than modulus of R1 minus R2. In this case, one circle completely lies inside the other circle. If C1, C2 less than modulus of R1 minus R2, then one circle completely lies inside the other circle. In this case, common tangents 0. Here circle's position is one circle completely lies inside of other circle. Okay? C1 C2 less than modulus of R1 minus R2. In this case, one circle completely lies inside of the other circle. Here number of common tangents 0. Number of common tangents equal to 0.